Hi everybody. So in this video, we're going to look at vectors and projectiles. In particular, how we use vectors with our Suva equations. Okay, so in example 1, we're told that a particle is projected from an origin with velocity 5i plus 12j, and this is in meters per second. The particle moves freely under gravity. Now in part A, we've been asked to find the velocity vector of p after 4 seconds and its speed at this time. So if we begin by resolving this upwards, then we know our displacement isn't being asked for or given, so we can forget about this. We know the initial displacement is given as 5i and 12j. The final velocity we've been asked to find, the acceleration, well, we know that gravity only acts downwards. So as a vector, this will be 0i and negative 9.8. Is negative because we're resolving upwards. If we were to resolve downwards, this will be positive 9.8. So we'll say 0 and negative 9.8. And the time we're given as 4. So to find this velocity vector, we can use v is equal to u plus at. But because this velocity is in itself a vector, we'll give this an x and a y value. And the initial velocity, 512. Now the time is a scalar, so we'll just have 4 multiplied by the acceleration, 0 and negative 9.8. So to work out the velocity as a vector, we need to work out both x and y. So x will be equal to 5 plus 4 lots of 0, so just 5. The y will be the 12 plus 4 lots of negative 9.8. So 12 minus 4 times 9.8. And this works out as 27.2 meters per second. Same for x. So as a vector then, v will be 5 minus 27.2 in column vector form. Then for part B, find the speed at this time. Well, we know speed is the magnitude of a velocity vector. So this will be the square root of 5 squared plus 27.2 squared. We can work this out and we get 27.66 meters per second. Okay, let's move on to example 2. Okay, so in example 2, we're told that a particle is projected from the origin with velocity vector 25i plus 18j from a point with position vector 120j, which is given here, relative to the fixed origin on the ground. The particle moves freely under gravity until it lands on the ground at point B. So if we make a note then that the acceleration will be 0, negative 9.8, and this is when we resolve upwards, we've been asked to find the time taken for the particle to land on the ground at B. So if we resolve upwards, we know the displacement will be xy. The initial velocity is 25 and 18. The final velocity we're not being asked for and it's not been given. And the acceleration is 0, negative 9.8. And the time is something we've been asked to find. So this time we can use s is equal to ut plus a half at squared. Now if we think about what's happening, initially it starts at 120 above ground level, but what we want is for it to land at ground level at B. So vertically it's travelled from 120 to 0. So the displacement then vertically would be negative 120. And this will be equal to the initial vertical velocity, so 18, times the time, plus a half at squared. And again, we have to consider the vertical component of the acceleration. So this would be a half of negative 9.8. So this would be minus 4.9 t squared. We can arrange this quadratic so it equals 0. So 4.9 t squared minus 18t minus 120. We can solve this quadratic, so t will be approximately 7.12 seconds. And then for part B, find the distance OB. Well, with distance OB, we can consider the horizontal component. So this time, we're trying to find the displacement x. We know it's got an initial velocity of 25. We know the time now is 7.12. Then for our second part of the equation, well, this will all go because this acceleration is 0 horizontally. So the displacement then will be 178 meters. Okay? Let's move on to question 3. Okay, so finally, in example 3, a particle P is projected with velocity PQ from a fixed point on horizontal ground. The particle moves freely under gravity and lands after 6 seconds at point A, where OA is 150 meters. We've been asked to find the value of P and the value of Q, and then the greatest height reached by the particle. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So again, if we resolve vertically upwards, we know the initial velocity will be PQ. The acceleration will be 0 and negative 9.8. Time is given as 6. And the initial displacement, well, this will be 150 in the x and 0 in the y. So 150, 0. We can use this 150 to set up an equation to find P. So S will equal ut plus a half at squared. Substitute in these values. The horizontal displacement is 150. The horizontal velocity is initially P. So this will be 6P. This A is 0, so all of this will go. So P will be equal to 25 meters per second. We can work out Q by substituting in our vertical components. So the displacement then vertically, well, it started at 0, but then came all the way back. So it ends in 0. So our vertical displacement is 0. So the displacement of 0 will be equal to 6Q plus a half at squared, well, half of negative 9.8 minus 4.9 times 36. We'll move this over to the left-hand side. So 176.4 will equal 6Q. So Q will be equal to 29.4 meters per second. And then for part B, find the greatest height reached by the particle. We know this is a parabola, and these are symmetrical about the maximum. So if it takes 6 seconds to go from 0 to A, it will take 3 seconds to get to the maximum. We also know our vertical velocity at 3 seconds will be equal to 0. And this has gone from an initial vertical velocity of 29.4. So we can use the formula S is equal to U plus V over 2 times time. We'll substitute in our values. So the vertical displacement will be 29.4 plus U over 2 multiplied by 3. And this works out as 44.1 meters. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.